All right, guys, so this is the last video for this next assignment, assignment 8.4, that's due this Friday. This is for PowerPoint 8.6 for molecular formula. So in the previous video, we talked about empirical formula. Now I'm going to finish it up and talk about molecular formulas. Okay, so previously in empirical formula, we talked about the lowest ratio of atoms in a compound. So if this is the molecular formula, C6H6, then the empirical formula would just be CH. So ionic compounds are always in the empirical formula. Remember the crisscross and reduce? Okay, so we always reduced the ionic compounds, but molecular are sometimes. So for example, NaCl, that's ionic, you can't reduce that. MgCl2, can't reduce that. None of these can be reduced. Okay. Molecular compounds might also be the empirical, might also be the lowest. So here's some examples. So water, can you reduce that further? No. So that is the same. So the molecular formula and the empirical formula for water are the same. For sugar, we talked about that last time. If this is the molecular formula, then that's the empirical formula. So all you have to do is reduce if I give you the molecular formula. For this one, the molecular formula is the same because this cannot be reduced any further. Even though it's very large, it can't be reduced any further, okay? All right, so let's talk about molecular formula, and this is the actual number of elements in a compound. The whole number multiple of empirical formulas. So let's say we have these two molecular formulas. What would be the empirical formula for each of these? And hopefully you come up with this, H2SO4, sulfuric acid, if you guys remember. Okay, so each of these could be reduced down to this. So this is a molecular formula and this is a molecular formula, but this is the empirical formula. Okay, so remember previously for the empirical formula, there were 4 steps. Percent to mass, mass to moles, divide by least, multiply till whole. That is empirical formula only. For molecular formula, there's 3 steps. So now we get to have only 3 steps. So for step number 1, you're going to calculate the mass of the empirical formula. So for this, if this is the empirical formula, we're going to add this up from the periodic table. 2 H's, 1 S, and 4 O's. So we need to know the molecular mass of this empirical formula. Okay. Step number 2 is you do molecular mass number divided by empirical mass number that you just calculated from step number 1. And I have to give you the molecular mass formula. Okay. Or the molecular mass number, rather. For step number 3, so you're going to get a number for this. So like 2 or 3 or 4, something like that. You're going to take that number, the answer for number 2, and you're going to multiply that number by the subscripts of the empirical formula. Okay? And if I just went over your head, just watch, and I will show you what I mean. Okay, so here's our first example. So empirical formula, let's get my pen up here. So the empirical formula for adipic acid is C3H5O2. The molecular mass, okay, so I am giving you the molecular mass. I have to, okay? You can't just guess. This is the molecular mass, okay? What is the molecular formula? So I've given you some information. So I'm telling you what the empirical formula is. I am telling you how much the molecular formula weighs, or the molecular mass. And then you have to calculate, based on those 2 pieces of information, what is the molecular formula, okay? So step 1, calculate the mass of the empirical formula. Make sure you keep 2 decimal places for this, all right? So we've got 3 carbons, 2 decimal places. We've got 5 hydrogens, 2 decimal places, and we've got 2 oxygens, 2 decimal places. So this is my mass for my empirical formula, okay? Step number 2, I'm going to do empirical mass divided by molecular mass. I'm sorry, I said that wrong. Molecular mass divided by empirical mass, okay? Or big over little, okay? We want to get a whole number, so it should be big over little, all right? So this 146 is from the problem that I gave you. I have to give you molecular mass, okay? This is what I just calculated, the empirical mass. So molecular mass over empirical mass, and that gives you this number right here, which is very close to 2. So you can go ahead and round that to 2. Step number 3, multiply that number, okay, by your empirical formula. All right, so if this is my empirical formula, I'm multiplying everything by 2. So 2 times 3, 2 times 5, 2 times 2, and we're going to get a molecular formula of C6H10O4, and that's the answer. Okay, so 3 simple steps. All right, let's try another one. Empirical formula was found to be this. So this time, I'm giving you the empirical formula, just like I did last time, and it's telling you that the molar mass is this. So I gave you the same 2 pieces of information. What is the molecular formula? All right, so step 1, calculate mass of the empirical formula. P2O5, we're going to keep 2 decimal places. Same thing as always. So here's 2 P's, here's 5 oxygens, and we get a mass for my empirical formula of 141.94. Step 2, divide molecular mass by empirical mass. So big over little. So here is my big, or here is my molecular mass, and here is my empirical mass. Okay, so 283 over 141, and that's very close to 2.00 something, something, something. Okay, so it's 2. We're going to take that 2 and we're going to plug it in for step number 3, which is multiply that number by the empirical formula. So P2O5 times 2, so 2 times 2, and 2 times 5, and we're going to get P4010, and this is my molecular formula. Okay? Now, what if, and it's quite, you're probably going to see this, what if you have to do both? So it says a sample of a compound containing 141 grams of nitrogen and 80 grams of oxygen. It has a molar mass of 220.1. Calculate empirical and molecular. So this would be a long problem, and this would be worth a lot because you have to do both here. You first have to calculate the empirical formula given the 2 masses that I gave you, and then you would have to take that information and calculate the molecular formula. So right now, I would pause the video, and I would see if you can do both of them on your own, okay, and then check your answers. So I'm going to go through this, and I'm going to handwrite this because I don't have the animation for this. So here we have nitrogen, okay? And for nitrogen, we have 140.1. I'm sorry for this handwriting, but okay. Fence posts divide by the molar mass of nitrogen, which is 14.01 grams, okay, and in 1 mole. All right, so we're going to get pretty much spot on 10.00. Now remember, this was percent to mass, mass to moles, divide by least, multiply till whole. I don't have percent here. It's already in mass, so I can skip step 1. Step 2 is mass to moles, and that's what I'm doing right here. And then for oxygen, okay, they gave me 80 grams. And oxygen off the periodic table is 16.0 in 1 mole. Okay, and that's spot on 5.00. The third step is divide by least. Well, 5 is lower than 10, so we're going to divide both by 5. This is very easy because it works out very nicely. 10 divided by 5 gives you 2. 5 divided by 5 gives you 1. The last step is multiply till whole. Well, each of these are a whole number. 2 is a whole number and 1 is a whole number, so I don't have to do the last step. It's very easy. So my empirical formula, okay, if N is 2, so we have N2, and oxygen has a 1. So N2O, and that's my empirical formula. So I just solved the first part. Okay, so we have an empirical formula of N2O, and to figure out molecular formula, I need to know the empirical formula mass. So what does N2O weigh? Well, there's 2 nitrogens and there's 1 oxygen. If you add that up, you get 44.01 grams per mole. So now I am going to take this mass and I'm going to take the mass they gave me in the problem, and it's molecular formula divided by empirical formula, or big over little. Well, my big is 2 20.1, and my little is 44.01. When you divide that, you get 5, or very, very close to 5. And I'm going to take that number and I'm going to multiply it to my empirical formula. So 5 times 2, 5 times 1, and you get N10O5. And that is my molecular formula. Okay? So now you guys should be able to do assignment 4, Unit 8, assignment 4. And let me know if you guys have any questions. Good luck. Take care.